Let's welcome Andrew, who came all the way from London, and let's make him welcome.
All right, hey guys. So I'm going to give you a talk today on better living through GitHub Bots. So who am I? I'm Andrew Svoboda. I am the Developer Tools team lead at Palantir. What is the Developer Tools team? We run and operate our GitHub, our CI system, our artifacting system. We run lots of vendor products. We run lots of our own products that we've written internally to fill the gap and the needs that we have for developers, which means basically, like, what are we doing? We're trying to build high quality tools all the time, and we're trying to build software and systems to make sure that developers can be as productive as they can be, right? That's like the main goal. It's like, our devs getting productive? Yes, we're doing a good job. If people tell us there's friction problems, we're doing a terrible job. You can find me on GitHub, and that's basically it. I don't really have any other social media. Sorry about that. And so today we're going to talk a little bit about laziness and compliance and the world from terribleness and how to get to a wonderful, friction-full, magical paradise. So what is laziness? It is minimizing as much effort as possible to solve a problem. You guys probably all are very lazy in a very good way, because we're all trying to write automation to get rid of our problems. No one wants to do anything by hand. And compliance is kind of following the best practices that exist that add accountability to those processes. So we maybe have this, diagram here of move fast and break things, super lazy, or maybe not lazy and not compliant at all. If you imagine you're in a system where you are doing lots of manual toil and effort and chores, things are broken, you're slow because there's like so much compliance process and everything, and that no one wants to live in that bottom left, broken things move slow. You can maybe be not lazy and you have to move carefully. There's some compliance stuff that you have to do, but everyone wants to be in this magical paradise where things just work, things are easy, things are fast, and everything is like well automated and nice accountability exists. So how do we get there? How do we move from like you just merge your PR whenever you want and you don't have any tests and you have no accountability to like a good place? So we have two practical examples today that we're going to kind of walk through, and I'm going to talk about the bots and the services that my team has kind of written around GitHub and around the APIs that exist to kind of solve some of these problems from first principles. So the first one we're going to talk about is operational changes in configuration as code. You can kind of think about this as like, modifying various like allow lists or something. And then the other one is going to be how you can update repositories at scale automatically without human intervention as safely as possible. And so we'll go into some of the examples here. So in this one, there is an operator and a user, and there's someone who comes up and says, hey, I have a new URL I want to add to this egress allow list. And you can imagine this process by hand is really slow. A couple hours later, because everyone's in different time zones, someone says, oh yeah, sounds good. Should we do both of these things? And then prompts on the user. But of course, because everyone's in different time zones, they don't get back to you, they're busy. Oh, it was on site all day, we only need this. And it's like 2 days later, and you're still waiting for changes, you have to confirm things. Finally, 3 days later, you're like, you've changes applied in production. Like, this is an easy change to make, and it takes a long time because the compliance is really bad and the process is really not automated. So we need a way of solving this that is self-service. Palantir is all about self-service, especially internally. Like, how do you make changes as easy as possible for developers? Because it's a developer-first organization. So what if like users could submit changes, and approve changes that are only relevant to their own customers and make this all entirely self-service? What if the operational teams could approve any changes that were necessary? So users can approve changes that are customer specific, and the development team that's doing all of the dev work can just like merge stuff into staging as easily as possible. So it's like cut down the amount of like work necessary as much as possible here. When we examine the state of the world and what exists out there, there's like not a ton of things that try to solve this really well. You have GitHub native reviews, which are pretty inflexible. They're not really expressive. You can't really add things together. Reviews are basically on or off. Code owners exist, and then you can require code owners to have merged something, but they aren't really that good. You can imagine this is like a pretty common problem if you have a bunch of configuration as code repositories and you want to be self-service. This is like really obnoxious. So Hey, look at that. We wrote a bot, a GitHub app that enables complex approvals and self-service workflows for pull requests. It's available open source. You can take a look at it. You can make pull requests. You can use it as a library if you want, I think. What does PolicyBot do? It's got a bunch of things. It can post status checks that are required with branch protection, which is really nice. So you can enable that with GitHub's API. You can define complex approval rules, either in the repository itself or at an organizational level, so users don't ever have to think about it. Approvals also support this thing called predicates. So you can say something like, only require this if a file has changed, only if this pull request is by an author, only if it targets a branch or a specific repository. And you can combine them together with ors and ands to generate like tons of expressive and granular conditions. So you can say things like, the size of or the number of files changed, or certain things that were modified about it. And it supports remote policy loading, which means you can reference other things and combine them together really nicely. So what does an example of this look like? For the example we just talked about, we have 3 rules here for our requirements. We want to make sure that the ops team is approved, the users can approve their own changes, and the dev team has changed staging files self-service. This is what an actual policy file looks like. It's relatively readable, I think. You can see that there's a top-level OR condition. So as long as any of the conditions are true, the policy passes. PolicyBot will post a successful status check. You can move on with your life, and you can merge really easily. So what does this look like kind of in practice? If the ops team has approved, you just have an author. Or if the ops team approves it, you have the author in the ops team. Cool, great. Relatively straightforward. If a user has tried to approve their own changes, so if you've only changed a specific path for, say, customer X, then it requires an approval by someone in the customer X team. Awesome. You now have self-approval on your files. Or if the dev team has changed staging files. So again, path-based approval. It has an author by the dev team. Automatic approval. No approval required at all. You have this nice UI, so you can evaluate rules. Now, this is a different one because that other rule I gave you was simulated. But this is the most recent human-authored PR in PolicyBot, and what the PolicyBot UI looks for that. You can see that it's got a top-level OR. One admin has approved, the policy goes green, and you're happy and you're good to go. So what does PolicyBot look like under the hood? It is a stateless app that receives and responds to GitHub webhooks. So you can run any number of PolicyBot nodes that you want. It works really well inside of a container distribution system such as Nomad or Kubernetes. It's totally event-driven, so it responds to GitHub webhooks and responds back asynchronously, so it doesn't eat up your GitHub webhook limits. It has no external dependencies. It's very easy to deploy yourself. And you can check it out if you want on Docker Hub. So thinking about the requirements that we had. We wanted to make sure that the operational team could approve their own changes. Check. We want to make sure that users can approve their customer-specific changes. Also check. The dev team is self-service. They do whatever they want in staging. Also check. Great. So now we've taken the typical exchange that we were talking about earlier, this example, and we've simplified almost all of it because we've removed the first 4 panels where the ops team has to get back to the user and everything and all of that stuff. We've totally simplified it. But we're not done yet, because if you can see right at the end, we're still waiting for someone to merge the PR. They're like, why, hey, that looks good. And then 7 or 8 hours later, we're still waiting for someone to press the merge button because you don't have right. That's silly. We can definitely do better. We know we can do better. We want to make sure that pull requests are merged once approval is given and all the tests pass. Cool, that should be really easy. Hey, there's another bot. We built another bot called Bulldozer. It merges pull requests. It is configured via YAML file, again, in repo or at the org level. It supports allow lists and deny lists via comments and labels. It can merge PRs with any part of the GitHub API that is supported by the API. So it does not clone repos locally. It just uses the API entirely. So it's very fast. But that does mean if you can get merge conflicts from GitHub and it will fail to merge. So it also supports keeping PRs up to date by using another label. So it will always merge in latest on develop. And I know that there's a new system in GitHub called auto merge, but you still have to manually press please start auto merging, which is kind of annoying because that defeats the whole purpose of auto merge to some degree. So Bulldozer works very well with just a label that you apply or in the pull request title, and it will just work out of the box once all of the status checks have passed. Internally at Palantir, in the last 30 days, Bulldozer has merged 140,000 pull requests across 3,000 repositories. It is a lot. It is constantly doing work. And that sounds like a crazy number because Palantir, if you look, does not have that many people. We're going to talk about how we get that many repos and how we get that many pull requests very shortly. What's its architecture like? Well, it's actually really similar to PolicyBot. It's really straightforward. It's a stateless app that receives and responds to GitHub webhooks. It's totally event-driven. It's totally asynchronous. There's no external dependencies, and it's also available on Docker Hub. So these are both nice, easy-to-use open source apps. And I think at this point, we've kind of hit all our requirements. We've made things really easy to use. We've made things self-service for users, and generally in a good place. So maybe now in this matrix of laziness and compliance, we've moved the needle a little bit. We've moved from like, there is no process or anything, and we have moved into slowly the magical paradise quadrant, but we're not there yet, right? Because like, we're just talking about people making pull requests. There's a more interesting example here, which is around automatic and continuous repository updates. So like I said earlier, and alluded to with Bulldozer, it's merged 140,000 pull requests across 3,000 repos. About 2K of them are involved in running what is Palantir's Foundry and Gotham platform. Because Palantir takes this approach to development, which we've called internally, and I think other people have called, which is known as the polyrepo approach. So rather than a large monorepo where you have all your code in one single repo, a couple of years ago, we decided to break everything out into small microservices where versions are, and like API dependencies are versioned across a wide range, which allows you to have independent teams that work well with each other and have like well-defined API boundaries, but it starts causing a lot of problems. Because what you realize really quickly is that how do you keep those dependencies up to date? How do you keep best practices, pushed everywhere to all of those repositories, to all those teams? And how do you keep your dependencies and CI configuration up to date? So while the monorepo can be really nice, the polyrepo can be really nice for development efforts, but you start to incur debt and problems in both places. So we need a couple things. And the first one that we need is we need a way for repositories to receive regular updates without human approval, without human toil. You can imagine if you want to update the CI for new best practices for 2,000 repos and it takes you only like 5 minutes, that's way too much time. You're going to spend like the next couple months just updating CI configuration. It's stupid. It's a waste of everyone's time. So we need a way of doing something different. There's a lot of things out there that try to do this, and a lot of them are focused on dependency updates, which is really good. For security purposes, getting your dependencies up to date is really valuable, but it doesn't handle everything. So Dependabot and Renovate are both great bots that exist out there. They're somewhat limited. That being said, they are open source. The tool I'm about to talk is not open source because it is a lot of stuff and its dependencies are not as easy to manage. It's not as stateless. But we built a thing internally called Excavator. And it is a GitHub app that automatically opens pull requests and automates away chores and toil effectively for users. So Excavator runs arbitrary checks in a sandbox container environment on a worker process. It's totally language agnostic, which means the code that you write can be Bash, could be complex Java code, could be Python, Go, whatever your favorite language is, you can effectively write it in an Excavator check. And Excavator takes that check and it runs it on the input of a repository, and it generates a pull request based on whatever diff that check produces. So basically, you run some script, can be anything you want. It's sandboxed, it has some allow listing features, so it can't just generally like talk to the broad internet. And it generates a pull request for you on your repository. You can imagine how kind of creative you can start getting because you're writing arbitrary code. It can do anything you can think of effectively. The biggest thing it does as well is it makes sure it queues all of that pull request creation up. So it rate limits itself effectively in terms of clones, in terms of like updates. So it's not going to overload GitHub and CI. You imagine creating 10,000 pull requests at once in GitHub. GitHub is not happy with that. GitHub explodes. We've killed our GitHub instance internally multiple times with Excavator. It is a great tool. But if you open more than 100 pull requests at once, GitHub gets very sad for everyone, and it does not run very well. In the last 30 days, Excavator has updated or created, so not like one or the other, but both, 400,000 pull requests across 4,500 repositories, and it runs almost 900 unique checks, which is kind of a crazy number. You imagine the number of repositories times the number of unique checks. It has to run all of those in a relatively reasonable amount of time, and then it's just pumping out pull requests constantly or updating them. So what does it look like under the hood? There is a primary coordinator process, and its job is to iterate over the list of installations that Excavator is installed on. So you can install on whatever organization you want, and it iterates through all of the repositories, takes a look at all of the checks that are defined, and it tries to determine a match of, should I run this check on this repository based on some really simple heuristics. We want to make these more complex in the future, but effectively right now it's just, does this repo name match a list of things that I would expect or a regex? But things you can imagine, I don't want to run a Java-based check on a non-Java repo. Like, that's silly. It's a waste of everyone's time. Hopefully the check exits early, but if it doesn't, you're just spending CPU cycles on a check that's going to produce nothing. Now, we have many worker processes as well that'll pull from the coordinator, and they register themselves and say, I'm done with my work. Can I get some new work? They execute everything in a containerized sandbox environment, because obviously these are all user-defined checks, and basically they're all untrusted code. So what we've provided here is Excavator is a giant RCE engine, which is, if you're in the security space, like really scary. It's also one of the reasons we don't want to necessarily open source it right away, because I'm sure there's some things that we need to fix about it almost right away. Workers all submit pull request patches that they generate after running on repositories to this pull request queue. And then the pull requests are all generated at a very slow rate in the background, so they don't overwhelm GitHub. We found empirically, you can only create an R instance of GitHub about 15 pull requests a minute, which is not a lot. And if you do more than that, GitHub just starts slowing down really quickly. This is our GitHub on-prem, but we run on AWS, and the instance is a R5 or R6i 24XL. So we pay Amazon a fair amount of money. We have a money cannon pointed at Amazon, and we shoot the money for our GitHub instance. But it's got, I think, 96 cores and about 100 gigs or 128 gigs of RAM. 15 pull requests a minute does not sound very fast, but when you imagine the constant, every time it creates a pull request, it sends webhooks to PolicyBot and to Bulldozer, who then evaluate, who then send them back to GitHub. CI gets evaluated and also sends it back. So you can imagine there's a lot of stuff happening under the hood when a pull request is created for the first time. So in Excavator, everything is background processing. The other two apps I mentioned, totally stateless. Excavator, entirely stateful. The coordinator needs to know the set of checks it's going to queue up. It needs to keep track of the work that's being done. It needs to make sure that it is correctly sending out work and distributing it evenly to all of its workers. We get some amount of horizontal scaling because the workers themselves are relatively stateless. They just care about registering, running checks, iterating over the set of things that they need to do. So we can run with about 35, 36 workers in prod without creating an everlasting queue, constantly basically churning on work. And you basically have to put limits everywhere in the system. You have to put limits on how often workers queue, how often they clone from GitHub, how often they pull from GitHub, and all of these are basically empirically found by us when we've chatted with GitHub before and enterprise support about having a busy instance. They notice the one user who is a 10x developer, and they're like, what's an SVC Excavator user, and why does he open so many pull requests every day? And he's the most productive dev at Palantir by far. So what kind of things does Excavator run under the hood? So the first one is obvious. We just chatted about them. They're dependency upgrades. In the Java ecosystem, dependencies are kind of funky because you can use a POM XML, you can use like other things. It's pretty non-standard because Java didn't ship kind of out of the box with like the one good system that newer languages like Go and like Rust have kind of like solidified around. Internally at Palantir, we wrote a thing and we've now open sourced it called Gradle consistent versions. It's a way of pinning your dependencies in a version lock file. You should check it out if you use Java. It is quite good. But it's not a standard thing. And so tools like Dependabot and Renovate fail to parse it. They fail to update it. You need a custom tool or a custom way of inferring what and how to interact with those things are. We also use Excavator for upgrading Gradle plugins, JDK versions, Go mod dependencies, Go versions, NPM lock files, PNPM lock files, Rust, Cargo, whatever you can think about, you can write a check to do it because it's almost all programmatic. And the thing we found internally is before this existed, a lot of people were using plus dependencies in their Java code. They'd just say like, I'll take whatever is on latest. And what you might resolve is different from what Marcelo might resolve, from what I might resolve. Our code might fail in different ways. It was kind of gnarly. Everyone had to move to pinned specific dependencies, but then you have the problem that you need to update those things. You need to update them regularly. And that didn't happen if you didn't use a tool like Renovate or Excavator, because it was just up to a human toiling away in the background every so often, running a thing on a Friday, scheduling an hour of their time and wasting their human time running chores. And no one wants to be doing that. We want to be productive engineers who are making forward progress on our projects, not doing chores. Other things that Excavator does, just raw code rewriting. So if you have a nice language, AST, and you can parse it and then you can make changes to it, you can do automated code refactors. You can do complex library migrations where you might be moving from library A to another library B, and you might be able to do that just on the fly with an Excavator tool. You might write a check to do it for you, or just any other sort of migration that you can think of. It's like a very powerful tool for automatically doing this. And again, it doesn't really matter if you have one repository. It's probably an easy price to pay. But if you have to do it across 2,000 or 3,000, it's intractable. It just takes too long. And it's really powerful for configuration as code repositories as well. You can imagine you have the same problem trying to like update complex YAMLs or JSON or whatever, changing or modifying Terraform code. And the biggest one that we found internally that I want to like evangelize even more is this idea around CI configuration templates. Everyone is like kind of hand managing their CI. Shouldn't do that. You should just have like one single template and it just gets updated from a single source of truth. And then as a developer, you don't ever have to think about your like circle YAML. You're not having to worry about that. You just like get whatever's the latest and greatest from the single source of truth and you move on with your life. We found that to be a massive boon with just the number of repositories that exist out there. Devs can focus on being devs and being productive, and they don't have to worry necessarily about what their CI looks like day in, day out. They get PRs, they're updated, they get new dependency updates, they move on with their life. So this is all well and good. We have automatic updates, we have these nice policies, but we have another thing that's even more meta, which is GitHub repository settings. How do you keep those up to date? Again, it doesn't matter if you're dealing with one repo. You can just configure it by hand in the GitHub settings UI. But if you have to configure 3,000 repos in the GitHub settings UI, you're gonna, throw yourself.
It's a lot of button.
It's a lot of button clicking, yeah. And I know that they just got purchased by Microsoft, and Microsoft loves button clicking, but like we don't, like it sucks. So actually, the other requirement here is that we have to manage all of these repos with configured, correct, and secure GitHub settings. So what's the state of the world? Again, there are things out there that do this. You can get away with some of these tools. Probot, this app here, is really good. Google even is working on something for repo automation bots. These both put the repository settings in the repository itself, which is really good. You get to have self-service repo settings. But if you have write access to those repositories, you can push a change that makes you the admin. And now you are the admin, and maybe now you can just do whatever you want. So it's not necessarily the most secure, and the requirement was like correct and secure things. We don't want to escalate anyone who has write access to be an admin of that thing. So surprise, we wrote another bot to do this called AutoCorrect. Its job is to enforce organization membership and repository settings using centralized config. So what does it do? It does everything in the GitHub API. It does everything for you that it can do. It manages teams, organizations, all the repository settings that are available to it on that particular version of GitHub Enterprise, because every version is a little bit different. It can sync GitHub users and teams via AD, Azure AD, LDAP groups, whatever. And it uses one single location for configuration as code. If you've ever used Terraform, you might be familiar with HCL. We use HCL internally sometimes. We use it in AutoCorrect to define easy to use hierarchical repository settings. You can use YAML, you can kind of use whatever language you want. It doesn't really matter. And what does it look like under the hood? It is, again, it's not a stateless app. This is a more complex app. Its job is basically a single long-lived process, and it receives webhooks from repositories that it operates on, and it immediately will apply settings when it sees those repositories show up. And then it will reapply in the background when the settings change as well. So if you go to the centralized config repo, you make a change, it applies instantaneously when that change takes effect. And then it runs a background job to always reapply just in case, if someone makes a change that it didn't detect, a webhook was dropped, timeout occurred somewhere, you still want to make sure you're going back and fixing things. And it has an API, so you can also plan changes and setting changes against it live to see what you might change. So if you want to go modify the default branch to include a new required status check, you want to see what you're going to affect. Maybe you think you're going to only hit 10 repos, you're actually going to hit 500. Maybe you're off a little bit, you need to change it, or maybe you typoed something. It can give you that feedback relatively easily. So cool, requirement check. Things can receive regular updates without humans, and we now can configure our 3,000 repositories in one single place relatively easily. So the idea here is that we've created this thing, like this bot synergy, basically. You can imagine all these bots are playing together now nicely. Excavator is coming along, it's opening pull requests, updating dependencies, it's making Gradle plugin changes or CI config. PolicyBot is now evaluating all of those pull requests, and it's checking to see whether or not they meet the right criteria. Are they signed by the right user? Are they coming from the right branch? Are they what are they modifying? And then they're allowing approvals to go through, so it's pushing up the green status check that it's approved. Circle tests are running to validate that you haven't broken anything semantically on that repository. And assuming they pass, it also sets it to success. AutoCorrect to set up the branch protection so that it requires CI and PolicyBot. And then Bulldozer is auto-merging those changes when all of the status checks pass. And so you can imagine here you've now created this nice system where you can start defining more complex behavior, and all of these bots are playing pretty well together. So here's an example of a policy where Excavator is playing well with PolicyBot. If the user is correct, if the signatures on the keys or on the commits are correct, it's only changing safe paths. For example, we don't really usually let Excavator automatically merge changes to source code, but a lot of the testing code or CI things, we want auto merging on. Requires 0, it goes through, passes, we move on with our life. And with humans, you have the same type of synergy, obviously. Humans can open PRs to modify source code and do whatever they want. PolicyBot waits for another review, and then you have the same set of things. PolicyBot is hooked up with Bulldozer and with AutoCorrect and all of the right pieces together to make it a really smooth experience for users. They write code, then they put a merge when ready label on their code. Someone approves it in a couple hours when they're at lunch. It auto merges, it goes into develop, and they move on with their lives. All of that is happening constantly behind the scenes. And now, maybe now, we've come into the magical paradise quadrant where things are not very frictiony. Everything can run pretty quickly. We're still pretty compliant. You're still requiring review on all of the right things. And developers are unblocked to do what they do best and just write code. We focused on that, and they don't have to worry about any of these other things together. So the philosophy that we found, I think the thing where this all works really well together is you build focus tools to fill specific gaps. You don't rewrite systems from scratch. You don't build a new GitHub because it's more effective for a team of 7 who runs all of these things, which is my team, by the way. We run all of these things and we're 7 people. it makes way more sense for us to build specific tools to hit specific replacement gaps than it is for us to, build everything from scratch. So be novel, build extensions. And these incremental improvements that we've built one at a time over the course of months and years all start to compound really nicely together. So you have we built PolicyBot to hit specific compliance rules. We didn't think about any of these things when we first built it. It was just one part of the laziness and compliance issue. Then we built Bulldozer because people would write code and they really wanted to just have their stuff merge when it got approved. And we were like, yeah, you know what? That is a good idea. We should do that. When Excavator came around and started auto-merging things, we were like, oh, this is really good. We've got we maybe have something here, By allowing these bots to really combine together, you get a lot more value out of them with a lot less work. We haven't designed a new system from scratch. We haven't built one big bot monolith or a new GitHub replacement. We built nice extensions to those things, and users get to use GitHub, and we get the benefit of getting regular GitHub upgrades with simple, straightforward tools. So I would encourage you guys, when thinking about that, you're building those types of developer tools that fill gaps and work well with the existing ecosystem, and you get all of the compounding gains of doing that as well. That's it. That's the talk.
I think we have some time for questions. Do we have a microphone somewhere?
Yeah.
That's the microphone.
Oh, this is the mic. Okay. All right. Makes sense. There you go.
I was just curious if you guys measured any kind of developer productivity within the company and the teams and financial gains and all that kind of stuff after implementing all this.
That's a very good question. It's a hard one to answer because we had that same question. How do you measure developer productivity? And it's not the easiest.
No.
It's a really hard question to measure. So it's almost a trap to spend too much time thinking about what was the financial gain of this thing, or that's at least what we found. The biggest way to measure it is, I think, your mean time to fixing bugs. How quickly can you go from there's a bug in production to the fix is now in production as well. And with these types of things, especially with dependency upgrades and a complex microservice web, it's really nice when you can say, ask Excavator, please run the dependency upgrade for service foobar that is broken everywhere, and it just does it for you. But have we actually done the exact math? No. But should we? Probably, but it's hard.
Yeah.
Yeah.
And is it even worth it at that point? If everybody's productive, it's it doesn't matter, we're productive.
Yeah, I think the biggest thing is trying to figure out, where there are friction points.
Yeah.
Where do you not know enough? Where are there gaps kind of in your site? Because some devs will just eat a lot of pain. Some people are very yeah, but I know it's too much of an internal thing to say, but yeah, lots of people just they're very good at tolerating badness. They get used to it, boiling frog syndrome. It's just it exists for long enough. Some people are really not, you're oh, this took me more than 5 minutes. I really want to get rid of that. But if you have a lot of devs or folks you work with who are pain tolerant, it can be difficult to notice when there are problems until it's too late and everyone's just really upset, and you don't want to get there.
Yeah, that's insanity to me. I'm the opposite. I'm nope, I don't want to do this again. So I automate it. And I got a lot of repos myself that I maintain. So I've been going down this GitHub bot in action road of automating everything that I can do. So I could sit, and my productivity has been going up. And you're right, I haven't measured it, but I feel like I crank out stuff quicker and quicker and quicker. And it started slow, but it keeps picking up. And like you said, it's just a little bit here and there.
Yeah, it's incremental and it compounds for sure.
Anyone else has some questions? All right.
Hi, so thanks for the presentation, very good. I was wondering, how do you test these kind of tools, especially when if you want to do some kind of stress test to see, so you understand that 15 PRs an hour, a minute, an hour will be very, very bad, but a minute is already passing the threshold. Probably there's other issues with GitHub or even with other stuff. How do you do tests or stress tests to these tools?
We found, so specifically testing GitHub or thinking about stress testing the tools themselves?
The tools.
The tools? The tools are a little bit easier to stress test. They are mostly, like I said, the two of them, Bulldozer and PolicyBot, they're totally asynchronous and they're totally webhook driven. So they fall over when you haven't allocated their like kubelet enough memory or like CPU, and you can see them falling behind. They both emit standard metrics that allow you to measure how many like worker background processes they're working at. So we have alarms basically. We use Datadog and like other really simple things like that. So we emit all these metrics from these bots. When they're maxed out, we know there's a problem. We often don't max those bots out. We max out GitHub first. That one is empirically figured out because we also siphon up all of the metrics from GitHub, and it has its own processing queue. And honestly, what happens with GitHub when you overload it is just everything gets slow. Like it all goes through the same set of like servers. Its API server gets really slow. The UI gets really slow. We found when it gets higher than like 1 second as like a P95, you've got a problem. You can like see it spiking, and you can see basically too much work being done. But we haven't found a good way to stress test GitHub. If you have a good way of stress testing GitHub, then like I'd kind of want to know about it.
Without hitting the API limits.
Without just ruining it entirely. Yeah.
Anyone else? Maybe I can ask many questions, but I don't want to. You mentioned many tools.
Yeah.
Four of them. They all are like this GitOps approach of configuration as code. But so first, who does the configuration? Is it you? Is it a team of people that know what best practices are? Because the tech stack must be quite dense to even keep up with everything. That's kind of my first. At Google, there was this system that you could do like widespread refactorings and widespread checks. But one of the cool things I remember was that you could actually measure the improvement performance. So sometimes, you have an API, so you have a library A and you want to modify library B, which has the same functionality, and you could get like a 30% improvement of the runtime of the services. But that involves a very heavyweight system because you have to basically open the PRs, do some, for example, get all the data from the tests and find out, okay, it took less 20% to run the tests than if I was using some other thing. Is it possible to do these kinds of things to kind of almost test wide range refactorings, or it's just more like just do it, merge, and then we'll see if someone complains?
It is difficult, especially with a polyrepo approach. Like I think Google benefits by having one big source, like one big repo where they can make those like monolithic and atomic changes. It is definitely harder to do for us. I would say one of the ways we do solve this problem to some degree is with changes that we believe will be performance-based or like performance-impacting changes. We usually cut release candidates of those changes before they get merged into develop or something. So they'll still get reviewed normally, and then they will go out to certain canary stacks. So we maintain like the Palantir SaaS platform basically is many different deployments that are all like basically single tenant for every kind of customer. So some of those are high risk in terms of they will accept more beta style code. We can measure the performance relative to other stacks that we know are running. So you can kind of test in staging stacks as well. But at some limit, it's not that you're testing in prod, but that you are evaluating the changes in prod. I really wish that there was a nice way of doing that in CI across many repos, but the reality is it's difficult. Yeah.
Okay.
In terms of the tech stack, who's managing the config as code, we try to centralize most things so that the teams that are like the central teams that kind of own some of these things can help make all those changes. So get the autocorrect piece where we have centralized config. My team is like the final say on basically all of those changes, but we try to give self-determination to orgs that have the capability to do it. Sometimes you have an org that's maybe like 2 or 3 people and they need more help. Sometimes you have an org with like 2 or 3 really big teams and like they already have maybe like a smaller ops team or something embedded in them. And here you go, here's your self-service, like go for it. In terms of Excavator, PolicyBot, and Bulldozer, they all have like config files that can be loaded from remote sources. So we try to create like single points of here's the remote source, and by default you just get that. If you want to override it because you need to change something about it for whatever reason and you believe it's not appropriate, you can do it. And we have all the nice, hopefully we have nice docs that it's easy to understand and do from first principles.
Okay. Can you I mean, I can keep going. Can you detect like, so this one of the tools was about making sure that all the configuration of GitHub is properly done.
Yeah.
You don't have to go to the UI.
Yeah.
Can you detect if, I'm not trying to say there's a malicious player, but someone just goes into the UI and starts clicking buttons that are not supposed to do? Can you have some sort of spike of, this is not, because you cannot disable the UI, I guess. I mean,
you can't disable the UI. Yeah. So what we do is autocorrect is hooked up to GitHub in such a way where it receives webhooks for repository modification events. Obviously, we use like the GitHub audit logs anyway, so you can see this in the audit logs. And you can run autocorrect in a couple of modes, where one of them is it immediately receives those webhooks and just logs it and says like, oh, user Marcelo has modified branch protections. Oh, that's interesting. And then let someone else deal with it.
Okay.
Or it can immediately respond back. And there's a small timing attack where it can come back. You can maybe, if you're really, really close with the merge button, you can maybe merge a change after doing the wrong thing. But largely we have like, the automation will eventually fix it anyway in the background. We use logs and we use like the metrics that we produce to try and find those effective bad actors. They don't often happen, and they're not really people that are like actually malicious. They're like, this thing is broken, I need to change it, I need to merge my PR anyway. We also have a bot that overrides those things and like merges and then leaves a nice paper trail, but it's more Palantir specific. It's just like a bot that can merge PRs and then files a Jira ticket for someone to go look at later. And it's like not fun at all to talk about. But
so one of the things we found is that because our app reacts to a lot of events, it's possible to create like loops.
Yeah.
Do you have this problem, or do you have a way to solve this way of like even multiple other apps that are, there is, for example, this app that basically every time you run a check, it creates a comment on the PR with all the results of the checks that fail, because sometimes people have like hundreds of checks. And then because you send a webhook with that, with an edited or a commented made, then other apps are triggering. So you have like this kind of self loops, like loops within like yourself or your tools and other part of the ecosystem. Do you have any thoughts on that?
A lot of the tools, we try to make these tools, one of them has to eventually be the thing that finishes that loop. That thing is mostly, in this case, Bulldozer. But that like dependency loop of like GitHub webhooks is really painful. And if it happens, then your GitHub falls over. Or if you're on .com, I guess GitHub just like tells you to go away and rate limits the crap out of you. We don't have anything to programmatically detect it today, but it would be really useful to have that. We just have to rely on the fact that a lot of the bots will stop processing if it's their event, usually. Autocorrect like doesn't log that it made changes, like that would be silly. So it quickly, immediately exits from the webhook processing code and returns back to GitHub. So all these like bots, when they receive webhooks, they also do that in an async way. So they receive the webhook, they put it on a queue for processing, and they immediately respond to GitHub with like a 200 like received, or 201 or something, whatever the appropriate status code is. You do that, GitHub is then freed from all its webhook processors, because that's where it gets blocked a lot. So if every bot were to like eat the webhook, wait 5 seconds, and then respond with I did the work, GitHub slows down a lot. So you want to like always process async.
Makes sense. No other questions? I'll ask Chris one last question. Just before can you share some horror stories, if there is any, of developers actively complaining about all this automation? Because I guess people, first of all, the base branch is always out of sync, right? So because there's so many PRs always being added that you don't control. That's one thing. And the other is just like people just complaining and trying to do like random commands on the thing, or even the onboarding for all these tools, because it's not so clear. Like, if you join Palantir, like, what do you do? Like, it's always.
I usually when we start like the new onboarding process, we start with that last slide. Like this one, basically. Okay. Like, here are the tools. This is what they're going to do. When you want to dig into them, when you want time to do them, you can dig in later. We try not to overload them with like all of the theoreticals that built the tools. But yes, there are definitely some problems with the approach that we take today. One of them is just, constant churn. Like, we have a higher load on GitHub. GitHub support always looks at us and goes like, you guys are crazy. What's going on? You've only got like 2,000-ish devs, and your system is like scaled to be like a 50K system, Part of that is the nature of all of this automation. We have all these webhooks that are getting processed. It's good for devs, kind of bad for us. One way I've seen it fail is that when you cut releases on things and excavators bumping tags, on versions and whatever. And you have some automation because you've already written a bot that can help people do releases, because, of course you would. Those things will cut releases every so often, and then everything comes around and you have dependencies literally in your product that just depend on other things in a big enough cycle where you're cutting releases all the time forever, and they only stops when you go on holiday, and everyone stops doing work effectively for a couple of days. So that's definitely a problem. Yeah.
Okay, thank you. I'll just last last question and we go for beers.
Awesome.
I'm a big integration unit testing guy, so I was just kind of curious from an integration testing standpoint. It's got to be a nightmare between all these tools. Do you even set any integration testing up between the tools to see how it behaves and catch things and whatever?
Most of the tools, yeah, we do. Most of the tools don't talk to each other. They talk to GitHub. So we trust parts of the tools that, like, it doesn't really matter if Bulldozer gets a response that a policy bot made a successful status check, that it was policy bot in particular. It just cares that, like, all of the status checks are passing and it can merge. So really what we're testing is integration against GitHub. That's like the main component there. In some tools like Excavator that have a lot more depth in them and like a lot more state, there's a lot more integration testing with the app itself. Most of the testing we run for those things are a bunch of unit tests, like lots of unit tests. In the case of policy bot, it's got some interesting response replayers for testing GitHub, like actual GitHub responses and sets of commits, because you want to make sure that, like, because we use PolicyBot as a security tool as well, that if there are like 5 commits, everyone in this room has maybe authored or amended one of them or something, and then someone else comes along and approves, you want to make sure that the policy is correct for whatever you've decided. And so there's a lot of edge cases there that we've built into the app. But testing against GitHub itself, because GitHub doesn't have a single container you can run that's just like running the GitHub, makes it kind of difficult. So we have like, you drop a token into the repo or into CI as an mvar. If that token is non-empty, then run additional unit or end-to-end integration tests against a live GitHub. So like maybe you create some repositories, then you delete them after the tests are done. And you do that in our staging environment. We don't do that to a prod. That would be nasty.
Okay, thanks.
It's not ideal. I wish there was a better tool for end-to-end testing against GitHub. If you have one, if anyone knows about one, I really want to know about it because it would make my life a lot easier.
All right, let's thank Andrew once more.
Yes.